Welcome class to Chapter 9, Spatial Joins. Spatial joins can be tricky to understand in the beginning. So along with these concepts in the lecture, we're going to spend much more time on this in the lab as well. And this is associated with Lab 10. So a spatial join basically joins two features that have a spatial relationship. And as you can see at the bottom, it keeps the features from the destination layer and then it adds to or appends the attributes from the source layer. So it is very important to understand which one is the destination and which one is the source for a variety of reasons with spatial joins. What you see here in front of you, the destination is cities, but the airports would be the source layer. The question probably is, which airport serves which city? So every city is going to get the airport basically that's closest to it, if we make that assumption that the closest airport serves the most people in that city. So we're going to go through a couple of examples, but I just want to kind of show you a simple example. Let's say we have areas of septic tanks. That's our destination. And you can see this area or this data set here where it says destination septic. But we need to know what geology is underneath. So what we could do is an inside join, which is like creating a spatial query using containment. But instead of querying, we're actually joining features based off of spatial relationships. So this formation is underneath the number 345 septic tank. So that field, which has 345, would be combined with this formation, geologic formation, and it would be used in the same table. You would see this in an appended table. When you create a spatial join, you actually create a new data set. So basically, if you're not doing an inside join, you probably are doing a distance join, which is based off of proximity. For example, going back to that question, which airport serves which city? If we're looking at, for example, the city of Adrian, we notice that Grande Union County Airport is going to be the one that serves it, probably because it's the closest. But you can also add in, well, it does this automatically, but it also gives you the distance of that source, which would be the airport. Cardinality is very important to understanding spatial joins. Just like when we were doing joins with the attribute tables, when we're dealing with joins with geography or the geometry of data, you must know the cardinality. So up here, instead of saying which airport serves which city, now you're saying which cities serve which airport. So notice how we flipped it. Because there's more than one city, we cannot simply add a whole bunch of cities in the data layer, because this is a one-to-many cardinality, and I'll talk about that in a minute. You can't add all the cities in the data layer for each record, just like when you're doing a relate, you can't like shove in a whole bunch of different data into one record. So what happens is you have to summarize the attribute fields, or whichever attribute fields that are there, and you have choices of how to summarize this. So for example, instead of having listed all the airports that this first airport that I highlighted serves, you are actually summarizing the number of people, perhaps, like population. So this is a one-to-many cardinality, and that means you, again, going back to the attribute table, you would have to use a relate, but using spatial joins, you have to use a summarize instead of a simple. So, airports to cities, one to many. So for each airport, instead of, again, listing all the cities, because you can't do that nicely in the table, it just summarizes those cities. So for that summary, it gives you a count. So for this airport, the Corvallis Municipal Airport, there are 33 cities with a population of 148,000 people. And you can kind of see that when you map it out over here, certain cities have different colors depending on which airport serves it. So down here shows a map, and it's a graduated symbol. The larger the airplane, the higher the population that airport serves. So going back to the geologic formations with septic, we'll say septic tanks, this is a 1-to-1 or maybe even a many-to-1. When we do a 1-to-1 or many-to-1, it's simple. We don't have to do any summary, just like when we're doing joins with the attribute tables. But when we do a 1-to-many or many-to-many, then we have to summarize the attributes. So for example, when the destination table is just 1, but the source table has many, then you have to once again summarize. And what's nice in ArcGIS is it gives you a count field as well. So this figure is an extremely important figure. I mentioned this again in the last slide, and it's also in your book. You can categorize each join into 4 major types. So we have our first type, simple inside. This is the upper left-hand corner. What we're at, and it all depends on your destination, your source, and your question. If your question is which county is each school in, there's only one county for each school. So this is a many-to-1, keeping in mind that the left-hand side here is the destination and the right-hand side is the source. Now we could flip this question around and say how many schools are there in each of the counties? So there's only one, it's only going to be one county for schools, so you're going to have to summarize the attributes of those schools. And remember, when we do a summarize, we get a count, so that'll help answer this question. All right, so those are inside joins. Then we can go over to distance joins. Which attraction is closest to each hotel? So remember, it looks like we're just looking for one for each hotel. If we're looking for just one, it's a simple. And in this case, this would be considered, once again, a many-to-1. Each attraction will just have one hotel, whichever one is closest. However, if we want to flip this around and say how many attractions are closest to each hotel, notice we're looking at the term how many. Anytime you're looking for a numerical value like that, most likely you're going to do a summarize. That's the key thing here. But if you're just looking for which thing, usually when you're just looking for one thing that's closest to another or that's inside another, you're going to do a simple. We'll talk more about this in the lab. Honestly though, this is the hardest part, is to figure out whether you need to do a simple or a summarized. Also, sometimes it's a trial and error. You might do it one way using a simple, and if you can't answer your question after you've done a simple join, then you might have to switch to a summarized join to see if that answers your question. So feature geometries, all, points, lines, polygons can all be related to each other, whether it's through a distance or an inside join. And each join basically just involves 2 geometry types, and it can be repeated. You can use polygon to polygon, you use points to points, you can use lines to lines, even though those aren't included here. So kind of like what I was saying in the last slide, one is usually associated with a simple join, and then the other is usually associated with a summarize. So again, if you're asking the questions, which county is each school in, that's a simple join. But if you want to flip it around, how many schools are in each county, then you use a summarized join. Okay, this is a little confusing, so bear with me. Remember, I just mentioned that the destination in these cardinality options, the destination is always on the left. However, unfortunately, when you do the actual spatial join in ArcGIS, they flip it around. So this is what this slide is about. They flip it around because they're saying something is attached to something else, so that something else is on the right and it's in bold. At least in the table I'm going to show you. This is just a snapshot of one of the tables that is very important to understand spatial joins. You will find the complete table in the book. Let's just take a look at the first one, points to points. You could always do a simple distance, or you could do a summarized distance. You can't do a simple inside because you can't, a point it has a 0 dimension, so you can't actually do an inside. So look at the two questions, or in this case it's just, they're not questions, but they're similar. Find the hospital closest to each town. Notice that we're just looking for one feature for this issue. So that means it's probably going to be simple. But if you want to find all the towns closer to one hospital than anything else, you will have to do a summarized. What if you're doing lines to points? So you can either do a simple distance, find the water mains closest to the proposed building site, or find the total voltage of the electric lines meeting at a substation. So that would be an example of a summarized inside. Polygons to points, simple inside or simple distance. There are other options. Look at the table in the book. That gives you many more options, but that will help you to understand what to do. Because remember, there are 4 choices when we deal with this, but the geometry will dictate some of those choices. But the 4 choices are, you could do an inside, simple, inside summarized, distance, simple, distance summarized. So let's take a look at more specific examples. So again, with points to points, we cannot do an inside because you can't have a point inside another point. We only use distances. So that narrows it down to simple or summarized. So some examples of distance, again, find the hospital closest to each town. Summarized would be summarize the attributes of the source features. So find all the towns closer to one hospital than any other hospital. You can't list all the towns, so you're going to have to summarize the attributes of those towns. For example, maybe that finding all the towns closer to one hospital than any other hospital will tell us how many people are closer to one hospital than another. Population is probably in the database of towns, and you can summarize that population. Points to polygons. Most of the time with points to polygons, you're probably going to do a distance join. You're actually probably going to do an inside join, but you could do a distance join. For example, in this case, we're looking at join each county to the hospital that's nearest. It's a little odd because the ones that are inside are just have a value of 0. Now this highlights something else that we're going to talk about, and that is what kind of coordinate system are we supposed to use when we deal with distance. This distance is actually in decimal degrees, which is not very favorable. So later on we'll talk more about what projections we actually need to use. So I kind of talked about this already, but this is important to know. When you're measuring distance from polygons, we always use the centroid. And if a county contains that hospital, then the distance is 0. And we'll talk more about that later. Here's something else that's interesting, points to lines. So because lines is the destination, what we're probably looking at is how many points are associated with each line, or more specifically, how many septic tank systems are associated with each river system or stream. We're making the assumption that the septic systems that are closest to each stream have the most impact. So sometimes you have to make assumptions and think about the kind of data that you're using and make sure that it can truly answer the question that you have. And again, those questions are sometimes answered through trial and error. I love for you guys to actually sit down and when you get into the tutorial, you will have a chance to sit down and really think about what the source is, what the destination is, what exactly will the final product look like, how can I best answer this question. If you could think all of that through step by step, you'll have a better chance of getting the output and doing the right join the first time. But if all else fails, there's just a few options, so you can do trial and error. And doing it with trial and error doesn't mean you're going to be doing trial and error all the time. You'll start to get more of an intuitive sense on which spatial join makes sense. Okay, so we have another request. Find the park that is closest to each road and give the road the park attributes. So basically we have roads, and whatever park is closest to it, we want all those attributes. So that's a simple distance. Here's something else that is, or here's a summarized inside option. Give the interstate the total population of all the counties that it crosses. So for example, what we're doing here is let's say we're taking this interstate and we're trying to figure out all the counties that it is inside. We can't list all those counties, so instead we want the population of those counties, and that's going to be a summarized field for that interstate. Polygons to polygons, you have several options. You got to think about it though. Simple inside. Find the park that each lake is inside and then give that lake the attributes of the park. So again, we're just looking for one feature for our destination and source. So for each, well, we could actually have a couple of, this could be a many-to-one, not just a one-to-one. But basically, for each lake, whichever park that lake is in, you basically give that park. You give that lake all the attributes of that park. What if we said give the park the total area of the lake it falls inside? Now this is interesting. Okay, so we're switching the destination and the source, but some lakes do not fall cleanly inside. So this may not actually work, because if we actually calculate the lakes within each park, and that lake isn't fully within the park, then we're going to get all of the lake that's both within and outside of the park. This is where Chapter 10 is going to be important when we deal with geoprocessing. Now this might work a little bit better. For a simple inside, give each urban unit the attributes of the county that it falls inside. So basically, we start with the urban area, which is just one, and we have county, which is one as well. Now there are multiple urban areas in a county, so this is technically a many-to-one. And that makes sense because we're using a simple inside. Summarized, give each county the summarized attributes of the urban areas that fall inside. Now we have a one-to-many because we're taking the urban areas and we're attaching it to the county. And it has to be summarized because there are multiple urban areas in some cases in some counties. Going back to coordinate systems, remember from Chapter 3 that geographic coordinate systems have a lot of distortion. Geographic coordinate systems also distorts distance in a major way. So if you are doing a distance join of any kind, whether it's summarized or simple, you're going to get a distance field, and we're going to be using the units of the coordinate system. Now, it doesn't really make sense, and it's not always accurate, to say that the distance is 0.474633 decimal degrees. Because that depends on your location, because remember, longitude actually, the number of degrees of longitude between each longitude line decreases as you go north until all of the longitude lines basically converge and meet at one point, whether it's the North Pole or South Pole. Also, when we're dealing with geographic coordinate systems, a lot of different states are greatly distorted, especially South Dakota here. So once again, it is a much better idea to use a projected coordinate system, because decimal degrees cannot be converted to kilometers or miles very easily. This is kind of a graphical view, distance drawing using a geographic coordinate system on the left, but then this one over here is using a UTM source. Notice you can actually get different results based on which projection you use. So this means you really need to use not just a projected system, but a projected system that does not distort distance. It conserves distance. Another caveat, you don't want to just use the data frame coordinate system to change it. So let's say we want to go from geographic to projected, and we want to make sure that projection preserves distance. It's not enough to just change the data frame coordinate system. All that does is temporarily aligns all the correctly defined data in the map. It doesn't actually change the properties of each data layer in terms of its coordinate system. So what you really need to do, bottom line, is you actually must project the source data, whichever data you're actually using to calculate the distance, using the project tool, not define project, the project tool, into a projection that preserves distance. Okay, so as you go forward in your lab, the tutorials will help you with this. The exercises that I will assign will be a lot more loose end. So these are a series of questions you might want to ask yourself as you try to figure out what your source is, what your destination is, and what the cardinality is, so you can choose the correct spatial join. What is the final output supposed to look like? What is the destination layer? Are we dealing with a distance or an inside? What's the cardinality? If you can figure out the cardinality, then you can easily figure out if it's going to be a simple, which is usually 1-to-1, many-to-one, or a summarized, which is a 1-to-many, many-to-many. Pages 262 and 264 highlight these. Well, it will give you extra tools to help answer these questions in the form of tables, figures, and text. Thank you, and see you next time.